Alright, today in Statistics A we'll be talking about measuring the spread. Now the spread is just the spread out of the numbers, and you've probably already seen this if you've done something that's called a box and whisker plot. And so let's draw out what a typical box and whisker plot looks like. Okay, so now a normal box and whisker plot is going to be perfectly symmetrical. Ugh, that's ugly. That is really ugly. Let's get rid of that. Let's go straight line. Okay, so in other words, this is going to be split right in half. Okay, and then the whiskers are going to be the same length. Okay. Now, box and whisker plot is going to measure out the spread, so this would be a pretty nice set of data. Now, if you were to look at it as a frequency plot, sometimes I hate drawing with a mouse just because you don't get it as well. Okay, some things we need to know. Okay, the lowest and the highest numbers are here. Okay, this is going to be the median, and it's also known as the second quartile. It's not talked about as much, but it is the second quartile. Okay, now this is the third quartile, and this one is going to be the first quartile. Okay, now here's an interesting thing. In order to find the first quartile, you have to find the median again between the lowest number and the actual median. So this is the median between the median and the lowest number. Alright, now to get the third quartile, you have to do the same, except it's with the median and the highest number. So you're finding the middle number in there. You do not count the median when you're actually finding it. So in other words, if your median appears as like a 0.5 and because it was an average of two numbers, to include the two numbers in finding the median, but if the median number was 9, do not use it for both the lower quartile and the higher quartile. Don't use it at all. Just use the numbers above 9 and the numbers below 9. So that's important to know when you're calculating and working with this stuff, okay? Alright, so that's how you actually find those. Interquartile range is going to be the third quartile minus the first quartile, and that's going to be important because when you're trying to find outliers, oh my gosh, I always forget this formula. Let me look it up real fast. Formula for finding outliers. I always forget this one. I don't know why I do this. And you need the interquartile range for it. So the formula is you take if you're looking for lower outliers, quartile 1 minus 1.5 times the interquartile range. Okay, and if you're looking for high outliers, and if it's anything higher than that, lower than that number, here, let me go back. Anything lower than this number, it is an outlier. Okay. All right. Now this one right here, for the third quartile, quartile 3 plus 1.5 times the interquartile range. Okay, and anything higher than this, is an outlier. Okay. Alright, so that's how you find the outliers with this, and that tells you the spread of data. Now, if you're dealing with outliers, you can get rid of them if you want, since they affect the mean. They don't affect the median as much, but they do mess around with the mean. Okay. So your 5-number summary is going to be the lowest number, the first quartile, the median, the third quartile, or the highest number. Oh, and just a quick trivia, if you notice I've got 3 quartiles, but I'm missing a 4th. I bet you can guess that the 4th quartile is going to be the highest number. Okay? Alright, that's it for measuring the spread. Oh, no, that is not it, because we need to go over standard deviation. Jeez Louise. Standard deviation. Because that is one of the most important things, because that tells you how your data is spread out. So let's go to my favorite website, mathisfun.com, that goes over the explanations. Standard deviation is just a measure of how spread out numbers are. It is the letter sigma. It's a lowercase sigma. The formula is easy. It is square roots of the variance. So what is the variance? The variance is defined as the average of the squared differences from the mean. So to calculate the variance, work out these steps. Find the mean. Then for each number, subtract the mean and square the result. Then work out the average of those squared differences. Okay, and some of you guys are probably asking, wait, why do we square it? Okay, why square differences? If we just add up the differences from the mean, the negatives would cancel out the positives. So 4 plus 4 minus 4 minus 4 divided by 4 would be 0. Okay? If we use absolute values, we could actually get the mean to be a little bit more interesting. It's like, oh, okay, that works. All right, now the reason why is some of the numbers are going to be lower than the mean, and some of them are going to be higher, so that's where we get these pluses and minuses. Okay, so if we use absolute values, that's fine. That looks good, and that makes sense because they're about 4 apart from the middle. So the middle is 0, so they're about 4 apart, so that makes sense. Whereas this one, that isn't 0 from 0, that isn't distance of 0. Okay? Now, and that is mean deviation, and that's something else entirely. But what about this case? 7, 1, negative 6, negative 2. They find out their spread to be 4, but if you notice the spread is not 4. Okay, so if we square it and then we square root the result, we can get the spread to be a little bit different. So this one does turn out to be 4, which works, and this one turns out to be 4.7, which gives it a little bit more standard deviation, just more spread out. Okay, this method is similar to discovering the distance between points. Okay, all right. So that's what we just want to talk about. Okay, so you and your friends have just measured the heights of your dogs. Okay, the heights of the shoulders are these measurements. Okay, let's go this way a little bit. Let's zoom in a little bit. Okay, find out the mean, the variance, and standard deviation. So the mean is you add them all up, divide them by 5, and the mean is 394. Now, if you look at the actual graph and stuff, you can kind of see that these 3 dogs are pretty close, but are the Rottweiler and the Dachshund, are they really far off? Okay, now you use the mean to calculate the difference. So this one would be 600 minus 394, which gets me 206. Then what was this one? 470 minus 394, which is 76. Then this one would be 170 minus 394, which would be negative 224. Then this one would be 36, and the difference here would be negative 94. Now to calculate the variance, take the difference, square it, and then add the results. Okay? So we square each result. We're going to get some really big numbers, and then we square each result, and then we add them all together, and we divide by 5, and we get 21,704. Okay, variance is not as easy to explain why it's there, but it's the square of the standard deviation. Okay, but now the standard deviation is just the square root of that, so that means that the spread out part is 147 millimeters. Okay, now that's the good thing about standard deviation, is useful. Now we can know which ones are within a height of 1 standard deviation. And as you can see, our suspicions were confirmed. The Greyhound, the Scotty, and the English Bulldog are all within 1 standard deviation. In other words, they're pretty close to the median. or mean, and then the Rottweiler and the Dachshund are outside of that. So these would be considered our outliers. So that's some interesting stuff. Now, I also love mathisfun.com because they have an amazing standard deviation calculator. By amazing, I mean is that they have the information set up and they take you through each process. Okay? All right, now this does come up to what the question I asked in the live lesson was why is there two different formulas? Okay. All right, you can read more about it here, but basically when you put your numbers into here, you would actually calculate everything into there. So you could have 5, 7, 9, 12, 19, 1, 8, and 4. Okay. All right, now is this the whole population or sample? Let's say it was the whole population. Now if it was a sample, that changes the answer. Okay, so watch this. If I go population, my standard deviation is 5.16, and if I do sample, it's going to be 5.51. Okay, so we're just going to look at population. So there's 8 numbers. The sum is 85. We divide by 8, and we get 8.125. Okay, so as you can see, the mean is pretty much balancing it out, except there's just some big numbers over here. Then we take each number and subtract the mean. So here's the subtractions. And then here's them squared. Okay, so we add them all up, and we divide by 8. Okay, and then we take the square root of that and we get the standard deviation. So that's pretty cool. So as you can see, the standard deviation, within standard deviation, about 6 of the numbers were within the standard deviation and 2 of them are not. Okay. All right, now if we did a sample, it changes everything. Okay, that just changes my variance and then changes my standard deviation. Okay. So as you can see, now we're closer to the bottom portion. We're a little bit closer to the top portion, but not by a whole bunch. It's about 0.4. Okay. All right, the spread out part of it is just this part right here. Standard deviation. Sigma notation. I just want to get to explain why it's n minus 1 and n. Okay, this is Bessel's correction. I always forget that too. Okay. Now the symbols also change. If you're working with sample, it's going to be x bar instead of mu, and the answer would be S instead of sigma. So if you're dealing with sigma, you're dealing with standard deviation of population. If you're dealing with mu, you're dealing with a mean of the population. X bar and S are the mean and the standard deviation of samples. Okay? All right, and you can look up Bessel's correction to explain why. I'm not going to go too much into it, okay? All right, but that's it for the measure of the spread, you guys. You guys have a wonderful day, and I'll talk to you later.